Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will talk about the isolation levels of a transaction. We will discuss each of this isolation level introduction, and then we will see that how can we implement this isolation levels so that we can reach the concurrent execution and also the serializability of the transactions. When we talk about the isolation, we must perform that each transactions are separated from each other in the same time of the execution. Now, when we are performing the concurrent execution of the transaction, then isolation becomes extremely important because without the isolation of data, we cannot give us a consistent result for the transaction. Say for an example that if two transactions want to modify the same data, then we cannot allow the same transactions are performing at the same time. So there must be an order in which they are performed either in a sequential way, other one need to wait for the other one to release the data. So how we can achieve this? We can achieve this with some isolation levels. With the greater isolation levels means that we are reaching is a non-concurrent execution. So the isolation and concurrency go for an inverse relation. So if the transactions are isolated from each other at the far, then we are not having the concurrent execution at the most. So when we are reaching the isolation level going down, then we are actually high down our concurrent execution. So the lowest isolation level goes for the most concurrent execution. But we should also take care of this consistency nature of a transaction or is a property. Now, how we can achieve this? By defining different isolation levels. We can introduce many of the isolation levels to reach this isolation property. Now, the first and the most of this isolated level is the serializable level. When we are saying that there is a serializable level on isolation, then we are saying that the transaction must be serial to each other. So the concept of serializability or serializable comes with the term of schedule. A schedule can contain more than one transactions, and we are considering a schedule as a serializable or the transactions that belong to the schedule as serializable when the transactions are performed in an atomic nature. That means the performance of the transactional operation are grouped together and they appear in the transaction together, not being interfered by any other transaction. So now we can call each transaction serializable transaction. This is the highest part of the isolation that one can get from this serializable level. So when we are putting the transaction as serializable, then no transactions can perform simultaneously even if they are belonging to the different part of the database. That means we cannot have any concurrent execution with the serializable transactions because the transactions cannot just happen concurrently because they need to perform their operations together in a part of the schedule. Now the next one is repeatable read. In the repeatable read, we can say that if there are two read operation that belongs to a transaction on the same data item, then between these two read data item operation for a single transaction, no other transaction can modify or update that data item or read that data item. So now we are modifying the data item by another transaction that it must not happen between two read data item operation for a single transaction. That means we are allowing the same data value to be read by the transaction as a repeatable read. That means it will repeat our read on the same data item for the same data value, not that the updated data value that we are allowing. So now we are actually allowing one more transaction to be concurrently execute with other transaction with one condition that it can update the data within these two read operation for a single transaction. Otherwise, it can update or modify the data consequently with these other transactions. So this is a less level of isolation, whereas it is a greater level of concurrency. Now the next one is in read committed. That means now we can data update on a particular value and the other transaction can read this. So suppose that TI are reading a value that is for a data item X. Now after that TJ is committing an update on that data, and after that the transaction is being committed, TI again is reading the value. That means now the TI is reading an updated value that is modified by the transaction TJ after the commitment of the transaction TJ. So now it is extremely useful to note here that read committed goes for the weaker level of isolation than the serializable or repeatable read, because now we are allowing actually the execution of the concurrent nature transactions to be happen simultaneously. And the last level of isolation that we can provide is in read uncommitted. That means even if the data which is not committed by any other transaction can be read by this transaction. Say suppose TI has read a data item X on any value, then TJ is updating the data value X but not committed the transaction. Now again TI can read this data value for some reason. So now TI and TJ are reading the same data item concurrently with each other but not providing the isolation at its least. So how can we achieve this concurrent execution while go hand in hand with this isolation level? So we can either provide a lock to the database. That means we are locking a database for a particular transaction. Now the database can access by that particular transaction and no other transaction can intervene this transaction without accessing the database. But this will obviously give us a lower level of concurrency because we are actually locking the whole database, which is not desirable, because maybe we are needing only a part of this database by the transaction TI, and there are several transactions which can access the different part of the database. But while we are providing a lock on this database, then we are actually having the database only locked for the transaction TI. No other transaction can access it until and unless TI is releasing the particular database. So now it is providing a greater level of isolation, but not a level concurrency that is acceptable. So now we need to implement this isolation level in such a way that we can achieve some way a concurrent execution, which is very much important in practice of between two transactions in a schedule. Now the first provide mechanism of this isolation level, that is locking. It is not about locking a particular database, but rather we can go for a tree protocol that the database are divided in areas, areas are divided in files, and finally files are divided in records. So we can either provide the locking mechanism to go for the records or at most the files. So the granularity that we are taking consideration, and we are providing lock to the finer granularity, leaving the coarser granularity available for the other transactions. So in that way we are allowing the concurrent execution, and also we are providing some way for the isolation level. Now when we are performing this locking mechanism, so we are actually having a lock on a particular data item. Say for a record we are having a lock on this data item, and after some time the transaction needs to release the lock so that other data item can be locked by other transactions. Now we can change these isolation levels in SQL by this transaction set transaction isolation level followed by the level name like the serializable, read committed, read uncommitted, in such a way. Now the greater versions of the SQL, like for SQL 1999 and later, the Oracle supports this transaction change to change isolation level to the name of this isolation. Now when we are performing this JDBC and ODBC connectivity, we can go for this set connectivity dot isolation level. In the brackets we need to mention the isolation level. Or now we can also check that what isolation level it belongs to by getting auto connect isolation level by property on a transaction set TI. So now in this way we can check the isolation level and also can set the isolation level including the SQL and JDBC or ODBC connectivity using this embedded SQL. Now again back to our locking. When we are performing locking on a particular data item, then we must assure two things: that we are acquiring a lock on a particular data item when we want to modify the data item. When we are performing reading that data item, there is no need to lock it, because reading a data item and to lock it that for way will give us a lower level of concurrent execution. Because if we can allow multiple transactions to read the data item simultaneously, because say for the airline reservation, multiple users can visit the airline site simultaneously, read the data that which selections of seats are available to them. Now when we goes for a selection of seat, that means the modification of the data, then we need to go for a lock on that data item, so that when we are selecting seat 1 and 2 for example, no other user are allowed to select seat 1 and 2 at that point of time. Now we can say that the locking is done at this highest level of finer granularity, that is at the modification level. And also the second thing, that we should maintain some time for the locks, otherwise other transactions should go for this starvation, or it can also arise in a deadlock. That means one transaction is waiting for a data item for much a longer time, that is he is starving for the data item, while other transaction is locked that data item for a longer period of time. So we can provide the two-phase locking protocol for achieving this section. That is, there will be two phases of locking. One is the growing phase, another is the shrinking phase. So in the growing phase, we can acquire all the locks by a transaction and its operation, and the shrinking phase we should release the lock. So this ensures two properties again. First one is no locks can be released while performing the acquiring locks, and the second one is it will not release on a particular data item lock too early just after completing the data item modification. Sometimes it is necessary to lock a data item for a specified period of time to provide consistency on the data item. Say suppose that item B has been modified with B equals to B minus 50. Now it is unlocking the writing data item after immediately the write has been performed. And now another data from another transaction can lock the data item and modify the data item. That will lead us an inconsistent result. So the two-phase locking protocol are free from this anomaly, that we can provide an acquiring lock phase and a releasing lock phase, so we can commit on a lock until and unless the transaction is committing. So in this way, two-phase locking protocol is absolutely important for locking on the isolation level. Now another isolation level implements locking in such a way that we are providing two phases. That means one is a shared mode, another is an exclusive mode. So when we want to read a data item, then we can provide a shared lock on that data item. That means now the data item will be locked, but if there is another data item that is waiting for a particular data item to be read, it can acquire the shared lock on the same data item simultaneously with other transactions. So now we are providing an isolation level and also an concurrent execution. Now the exclusive mode lock goes for when we want to store the data and modify it, then we cannot have another transaction to lock that data item either in an exclusive mode or in a shared mode. That means until now and unless the updation has been performed at its atomic nature, then we cannot update the value, or either we cannot read the updated at the middle of this value. Now, unfortunately, some database designer go for a weaker level of isolation where made this set of isolation level as serializable. That means the isolation level is set to serializable, but is it implementing some weaker level of concurrency or the isolation level? So that leads us within serializable schedule or transaction with some non-serializability in nature. Say for the example, if we are providing this locking mechanism on a finer granularity as well as a coarser granularity, then we cannot maintain the serializable nature of transaction in a schedule. But the set of this level is in the serializable level. So what we can do, we can provide by implementing at the most what we can do for the vehicle level of consistency. Another way of implementing this isolation level is to provide a timestamp. See, for the locking has the disadvantage that one way it will go for the deadlocking on this transaction. So TI has locked for a data item that TJ is requiring, TJ has locked for a data item that TK is requiring, and TK has locked for a data item that TI is requiring. So now we are living in a situation where the system is being deadlocked while providing this locking mechanism. So now what we can do, we can either go for the deadlock detection, the deadlock avoidance or deadlock prevention, but we can provide a better mechanism than locking to achieve this isolation level. What is this? This is a timestamp. If for each of this transaction we associate a timestamp, say a static or a dynamic timestamp TS with it, then we can measure that which transaction is appearing after which transaction, as thus we can maintain that we will acquire that lock or we need to acquire that lock. So either there is a wet and wound or other is in wet and die applications based on this timestamp. Say for an example, two transactions TI and TJ are there and their timestamps are TSTI and TSTJ. Now there are two more timestamps that is associated with it, W timestamp on a data item Q and read timestamp on a data item Q. So now if we can perform this R timestamp as the largest time to read that data item on that particular data item Q, then we can say that TSTI can have write this data item if it is less than this R timestamp Q. That means the R timestamp Q, the read value will be happen after the write value that is performed by the transaction TI, and we have calculated the timestamp as TS. So the system clock that we will mark for each of the transaction at the entrance of the transaction or the beginning of the transaction, and the end of the transaction will mark for another entrance of the transactions. So in this way we can use the timestamp as a very good efficient method for getting and implementing an isolation level, also for an concurrent execution. But the timestamps unfortunately doesn't always support serializability, because the serializable nature of the transactions will go for every transaction for TI and TJ. There will be TSTI less than TSTJ if TJ is appearing after TI. So now we are having in serializable nature of this isolation level that we can provide within timestamp. So the timestamps can provide us to ensure that the data will be ordered and accessed in the exact order on the transactions that we were mentioned it in the transaction. The next way of implementing the isolation level is in multiple versions and the snapshot isolation. So what do you mean by multiple version? So that now we are having a set of value for a particular data item Q for the multiple versions of the data. Now we can choose for reading an older version on data rather than an updating version of data, which becomes possible with a multiple version scheme for a data item Q. So that in the set of data items, say QI to QN, QI is the largest and the oldest value for Q, and QN is the newest value for Q. So now a particular transaction can maintain whether it needs to read the data value for QI or for QJ or for QN. So in this way, the multiple versions of data can be supported at the isolation level. So it is the highest level of isolation that can be implemented with the multiple versions. So now if a transaction Ti is reading a value for Q for the version Qi, another transaction for Tj can read the value of data item Q for the versions of Qn. So now the two transactions are accessing the same data item at the same time but with two different versions. So that is why multiple versions are often applied to many of the systems like SQL, PostgreSQL and Oracle to support the levels of isolation at its best, like is the serializable isolation. Now the multiple versions of the isolation level goes for another concept introduction that is known as snapshot isolation. Like at the beginning of the transaction, there will be a snapshot that will belong exclusively to that particular transaction of that particular data items that he or she will need to perform this transaction. Now, each transaction has its own copy of data item for that particular data item. Say now Ti have the data item Q for that transaction Qi on the snapshot, Tj as Qj, Tn as Qn. So now the same item Q has got three different copies of it, maybe which is same at the beginning for three different transactions. So now these transactions can concurrently execute with each other while also we are maintaining the isolation. Now, if Ti, Tj and Ta are reading the data value at the same time, no need to log that data item. It can allow the concurrent execution of reading that data by having reading the own copy of the transaction. That means Ti will read Qi, Tj will read Qj, and Tn will read Qn. Three of us will get the same value but with their indifferent copies. So now how can we go for a modification? When say Ti is updating the data value item for Q, then it will update it on the section or the snapshot of Qi. And now Qi will store the version of data that is being updated by Ti, Qj for Tj and Qn for Tn. So now when in letter var the Qi also read by this Ti, then it will be read the value that Ti has updated, not the value that Tj has updated. So in this way, we can store the different updated versions of that same data item, not in the actual database, but for each transactions for isolation level. Now the transactions can read and modify their data. Now this improves this performance level at its most because it provides a greater level of concurrency, at the same time greater level of isolation. So there is no need to restrict all the read data items that can be performed concurrently with slight restriction to the modification or the write item that it can perform to its own copy, but one cannot have the update of this another copy. Say Ti is updating Qi and Tj is updating Qj, then Ti cannot see the update of Qj what it is having, while Tj cannot see the update of Ti what Qi has made. But if in contrast to this locking, one Ti has completed and released the lock, it can see that what Tj has updated the value on data item Q. But in snapshot isolation, we cannot provide one transaction should see the update of other transactions. So in some way that is a little bit problematic, but generally it will improve the performance level at the highest one because it provides the concurrency with the isolation. Now Oracle, PostgreSQL and SQL, three of these provide snapshot isolation, but this snapshot isolation not always provides serializable transactions because serializable transactions are itself performed together. Now if one transaction cannot see the update of the isolation on another transaction, then what is the meaning of isolating that transactions from each other? We cannot have the result of one transaction as an input to another transaction as in a sequence if we follow that. So even if this tree, Oracle, PostgreSQL offers serializable nature and also it offers some of the features of snapshot isolation, it cannot go hand in hand by this both of these two. So that is all for this implementing this isolation level like serializable, repeatable read, read committed and read uncommitted with the levels of implementing it as locking, timestamps, multiple versions and also snapshot allocation. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.